Hello everyone and welcome back to TritonTv. Let's do another Mastercam video. We'll just pick up where we left off. Today we're going to be doing the Titan-1-2M and we're going to try to pick up the pace a little. So if you end up finding this series in the future when I have 60 million subscribers in my own machine shop and I'm training people and we're making awesome videos, this is where it all started. Anyway, so first thing I'm gonna do, I went ahead and created a template. I'm gonna merge. So I'm gonna go to File, Merge, and I have oops, here it is. I have this template I made here. All right, and we're just gonna push the green check mark, let it come in. So this is the Kurt Weiss, and I have changed a few things. Actually, here's what we're gonna do. So we are in the top plane. I went ahead and got the vise all lined up with that. One thing we're gonna do, we're gonna do a couple things for. We are going to go to Boolean in the solids pane here. It's like one or more tool bodies. Let's add this guy, that guy, and this guy. So we're going to add all these together so all the moving stuff is one entity. So it's just easier to move everything forward and back. So I'm going to go ahead and save it again. Anytime you merge, it's going to double check that this is what you want to save. So anyway, here we go. So now we got our vise. And we're just going to, I went ahead and made the DX6 template on level 100. And so level 1 is going to be called Titan 1-2M. Titan 1-2M. All right, let's get to drafting here. What we're going to do is go ahead and turn off the vise. This is actually going to be called Geo. And then I'll copy this, make the level 5 solid. Here we go. Save it again. Let's do a different color today. Let's use green. Maybe I used green on the last one. It's pretty much the same part as the last one. So I guess you could just keep the draft of the other one, but whatever. We'll draft it from fresh. It looks like it is 4 inches by 1.9. There we go. Anchor to center. Boom. Actually, yeah. Okay. And yeah, I'll leave that. I'm thinking ahead. All right, so we got the main profile of the part. Now we're going to translate the profile down the thickness of the part. Oh, weird. This... I think they forgot to mention this. Weird. This print doesn't show the thickness of the part, but we're just going to assume it's the same as all the others. I think that's how they want to do this. Yeah, it's looking like everything overlaps. Maybe that's how you're supposed to do this project. Who cares? Whatever, we're going to make it 750 thick. So we're going to copy it in Z minus 750. There is our wireframe entity of the part. Oh, I did all that on the solid. It's okay. Copy all this. Move levels to there. Turn the solid level on. Let's do a fun color. Let's do like bright blue. We're going to extrude this guy that direction, like 750. There we go. So now we got our main solid body. We're going to go back to the Geo. Let's start making some holes in here. So there's a pretty cool function. It's like old school Mastercam. I think a lot of the new users don't even know it exists. So these are going to be, looks like 1032s down a minimum of 380. I don't know if they're through. We'll act like they're blind. It doesn't say don't break through. Kind of bad printmaking, to be honest. Whatever. We're going to draw the minor diameter, 1032, which is 0.159 is one of the tap drills. So now that I have the hole selected and locked, I can actually just start typing in numbers. But what we're going to do temporarily is, actually, here's what we're going to do. We're going to duplicate the top plane. We're going to call it op1. And temporarily, we're going to move the origin to where all the numbers come from, because it'd be a million times easier to draw these holes. I hate using the corner, because when you're picking up on stock, if the stock's not the exact same size you draw, you'll be removing more stock from this side. So I like center. We're going to move that in a sec. Anyway, let's start drawing these holes in here. So we already have our number, and I'm going to go to the top view, and we're just going to start typing in dimensions. 0.150, comma 0.150. I think you can hit enter and it'll just, oops, I meant to go negative. Let's move this, minus 0.3. There we go. There's our first one. Oop, something that's hard to see. Let's do this. We're going to change all the blue stuff. So we can go to select all colors, blue, or no, Jesus Christ. Select all colors, green, and we're going to make the green stuff orange. And I'm going to change my color to orange. Okay, let's start making more of these holes here. So we got one at 1.15, comma 0.3. I keep forgetting to put negative. Let's do that. Minus. Wait. Gosh, I'm doing this all backwards. 1.15, comma minus 0.3. There we go. Now we got that one. And then let's do 2.85, comma minus 0.3. Enter. Let's go ahead and do 3.850, comma minus 0.150. There we go. Let's go ahead and do that real quick. Just take a peek, make sure everything looks good. And now we got about 3 more holes to do. So open that function back up, and we're going to type in 0.150 negative 1.75. And then the next one is going to be 3.850, comma minus 1.75. Oop. There we go. And since these just call out, oh, I forgot one hole. Let's see here. This one's going to be at 2 inches, comma minus 1.216. All right, real quick, we'll just double check positions here. 150, 150, that looks good. 1.150 minus 0.3, that looks good. 2.85 minus 0.3, that looks good. 3.850 minus 0.15, that looks good. This is 2 inches minus 1.26. This is 0.150 minus 1.75. And then 3.850. Okay, now I'm going to move my origin back. There we go. And it just says a minimum of 380 deep for tapping. Let's thread mill this. So we really only need to drill half a pitch or pitch so. Let's just extrude this 1/2 inch deep. So we're going to be in solids, we're going to extrude, and we're going to make sure we're going to pick the same direction on all of them. So I'm picking above the midpoint on the right. If I were to unselect one and pick below the midpoint, it'll swap the direction. No big deal. You can just click reverse. So if they're all the same direction, and we switch to cut body, they're all going to extrude properly. So those are going to extrude down 1/2 inch. Boom. We can draw the chamfer. There's a couple different ways to do this, but let's go ahead and do it. Let's do it like this. Save it again. And these are 210 chamfers. So what we're going to do is we're going to take 0.21 minus 0.159 equals divided by 2. That's going to be our why can't I chamfer? So we're going to chamfer all of these edges here. And we're going to chamfer them 0.0255. There we go. That's one way to do it. There's like a million other ways. You can draw an axis and then draw the angle and then revolve cut. There's like a billion ways. So let's go ahead and analyze this. There's our 210, right? So that's about 10 thou per side chamfer, countersink, however you want to call it. Those are 1032s. All right, so we got our part drafted. And let's go ahead and create one more level. We're just going to call it, I'm just going to call it profile. I get lazier and lazier as I do these. So we'll take the geometry here. We're going to copy it. I'm going to change it to my color that I like for profiles. This guy here. And we're going to turn off the solid because of that stupid glitch. We're going to go to wireframe. Do 10 thou fillets. Did that one do? Okay, yeah. I'm really lazy with my clicks right now. It's amazing they're even working. Oh, let's turn the solid back on. All right. The next thing I want to do is I want to position the vise. So let's do, oh, we have one more thing. I'm a liar. Let's just call this level 6. Stock geo. Turn off the vise. Switch to red. There we go. And let's learn some new functions here. Let's go to the geometry. And we're going to offset a chain. Offset this guy. Oop, this direction. 0.125. We're gonna copy it. Okay. We're gonna go to chain selection, click on this guy, and we're going to copy it to our stock, right? Then we're going to, yeah, did that right? Yep. Then we're gonna change the color. We're gonna go red. And let's see if I remember what size we picked last time. I think we picked 1 inch. So let's just, yeah, let's move this up 50. There we go. And we're going to do blue check mark, click it again. And we're going to do -1.0, copy. Let's see, let's take a peek at that. So we have 50 thou stock above here. And then below 200. So we take 0.2 minus 0.125-ish. That's 75 minus how far we're profiling will be above the vise by 25 thou. Perfect for me. Now that we have the stock geo, let's get the stock solid. Okay, and then we're gonna extrude this guy. We're not gonna cut, we're gonna create a body. There we go. And yes, it is on that level. Make this red. All right. And before we go into the stock setup and all that stuff, let's get this positioned properly. So from the front of the vise to the back of the stock, copy this number, and we're going to move everything in the vice level. We're going to translate it this far. There we go. And then we're going to measure when it's done. There we go. Pretty close. We're going to measure from the front of the vise to let's do that again. From here to there, minus 0.1. Okay, so 0.1 is how far we're going to move front jaw stuff. Okay, next we got to get this vise placed. We'll do it this way. So we're going to take 0.625 minus 0.785. So 840 is how far we're going to move the vise down. Ta-da! We have our stock placed. Alrighty, I'm just going to save that guy there. And let's go ahead and go on into, yeah, just wanted to check something real quick. All right, let's go ahead and go into our stock setup. And yeah, we'll just pick this guy here. Okay, let's go ahead and pick that. Let's see here. What am I trying to do? We're going to use a level this time for DX6. We're going to rename that op1. There we go. And we're going to use tools, step back and coolant. We're going to import tools from our last setup too. Let's go ahead and pick the Hermeli again. Hermeli. Not going to move anything. We'll just pick OK there. We'll go ahead and save it. And what we're going to do is we're going to open our last program. There's a few different ways to transfer tools over, but we're going to open our last program. Since we already have all the tools. And what we're going to do is we're going to go to toolpaths. We're going to go to the tools manager. And we're going to create a new tool library. We're just going to call it Titans of CNC. Right? We're going to save it. What we're going to do is we're going to bring our tools down here into that library, push OK, and it's going to ask if we want to save it. So yes. Save this just because. Now we're going to go back to the Titan, the new one, the 1-2M, and we're going to go to our tool manager. Real quick before I do that, I want to show you one setting that'll mess your tool numbers up. If you have this on, it can mess up your tool numbers when importing tools. So I turn it off when I import tools. And we're going to go to the Titans of CNC, bring our tools in. Boom, now we got our tools from last time. So you notice we're kind of building templates. We're getting things done faster. So now I'll go back into the tool settings and I'll assign them sequentially because we're going to need more tools. Save it again. And now we could start tool pathing. And if we're really lazy, we can just import our tools from our program. We're going to find our program. Let's see. So select our program from last time. And we're just going to import these. We're going to disable, we're going to import op group. We'll have double. It'll add a 1 to this toolpath group. Let's see. And we're going to remember the file. So we're going to import all these toolpaths. We're going to disable duplicate tool checking because I already imported the tools, and we're going to import the op groups. I think that's all we want. Let's push OK. All right. So now we have our toolpaths from last time. Teach you a hotkey, Alt-E. will collapse all of these. Out here, it's that temporary level, but inside the toolpath manager, it'll collapse all the toolpaths. So we're going to go ahead and delete that. So now we have our op1 and 2 template. Oh, one thing too, it's going to import planes here. So we didn't have, let's see. Yeah. All those toolpaths came in with this other plane, and I think they're going to be, let's see, I think it's going to be 90 degrees of this plane. Yeah, because of the way the vise was set up last time. So the first thing we're going to do with all the op1 toolpaths that we imported is we're going to select on the toolpath group, right-click, edit common parameters, and we're going to go to planes, and we're going to change this to our new op1 and move everything across and push OK. And now when we go to the planes manager, we'll notice this plane isn't used, so we're going to right-click it and we're going to delete it. I also want to point out it says op2 plane isn't used. This is an interesting, like, it's what I call a ghost anomaly. When you import tools, there's certain weird things that happen. So you see how they say op2 work coordinate system and tool plane? You would think that it's using this. It's actually kind of like what I call a ghost plane. It doesn't actually exist. So it's something you have to be really careful of when importing ops. If you have similarly named planes from your new file to your old file, you want to explicitly call those out. So what we're going to do is we're also going to do that to op2, because they're all dirty toolpaths anyway. So we'll just really make sure we're using our real op2 plane here. And one dead giveaway that it does change things, we're going to change this to, let's use offset 3. Well, we'll do that later. If you had clean toolpaths, it would make them dirty, and it's a dead giveaway that there was a different, like, ghost plane there. Kind of an interesting, I want to say it's a bug. It's been introduced for a couple years now. Okay. So we have our template toolpaths. We replaned them before we started. We're in our offset. I'm going to do one more thing. I'm going to explicitly call this offset 1, push OK, and then op2. Haha. That's that imported plane. We're not even going to use it. We're going to make we're just going to call this op whatever. We're going to copy our op1 plane, duplicate, and then we're going to call this op2, make it our main, rotate it about Y, and then come to the bottom of the part. Go to our plane, right click on the Z value. There we go. So now we got our planes set again, right in the middle of the part. We're going to save it, and we're going to delete this other plane. It might not let us, because the tool, oh yeah, there we go. There we go. And I'm going to, yeah, you see how it got rid of the tool plane? Do this again. Okay, we're going to call it op2, move it over. Why does this, did I not explain what op2 is? Oh, weird. It changed it. I've never noticed that. Okay. Sorry for that weird conundrum of the setup there. All right, so we have our little template built out here. And did we set up stock? Yeah, we did set up stock. They really did mess up facing. It used to just import. Weird. Whatever. We're going to come in here. We're going to add our facing stock. How is that not a chain? I think I have some duplicate action going on here. So we're going to go to home, delete duplicates. Yep. I don't know how I did that. Might have done that when I was making the Stock profile. Oh wow. So we're going to add our chain for our facing. Green check mark. Just go back, double check what we had set from the other part. Just zigzagging. Sure, why not? Okay. Let's turn some things on here. Alrighty. Boom. This is the nice thing when you do like similar parts. Like technically, if I made all three of these parts, they'd probably all be in one file. And the only thing I would change is like the new drilling and whatnot. I would do this exact same profile on the outside, but whatever. We're doing videos from scratch, so no big deal. All right, so now we're going to go ahead and do the same thing as last time. We're going to add our chain from the profile level so we can lead in on the corner. And since we already know the settings are good, we're just going to regen. Lead in from the corner, ramp down 50 thou, leave 10 on the walls. This time we are 800, yeah, we're about 40. I think I misspoke earlier. We're 40 above the vise. Just double check. Inch and 5/8 parallels. All right. We're going to go ahead and add the chain for facing. There we go. Add the profile. Haha, there we go. Okay. We got our profile there. And same thing, add our deburr profile. All right. So now we have the main block programmed. Notice how it was like way faster than last time. This is kind of the point of when you program similar parts and you already have the base built up. You can export ops and import them. You can import them directly from the other op. The one thing that's good about exporting toolpaths is, I guess I could do this. If I right click and go to, where's it at? Oh, this might be interesting. You can import, but you can't export on the Learning Edition. No big deal. One thing, what I was going to say is if you export toolpaths, you don't have to worry about the weird planes coming in because there are no planes to exported ops, I believe. I just did it today at work. All right, so now the only thing we really need to add to this is our spot drilling and yeah, spot drilling, and thread milling. So what we're going to do is we're going to go and we're going to do a drill toolpath. And you can pick the, let's clean up the screen here. Let's just leave the geo on, turn off the solid, everything else. And you know what? We could get really persnickety and just leave those on. And then we can drill, select everything, automatically gives us a sort. If you don't like the sort, you can change the sorting type down here. There's like a bajillion different ways. I don't get too focused or hung up on it. Looks good to me. And we don't have a, oh, weird. I didn't even notice that. Let's clean that up real quick. I didn't even notice. Disable duplicate. Oh, maybe I should have left it on. Here's what we're going to do. Just pretend I didn't do this. This is going to be, ah, shoot. This is going to be tool 1. I totally messed that up. Update assembly. This is going to be tool 2, right? Gosh, I messed that up so bad. Let's take a peek here. Looks like they match to me. Okay. So we have our drill toolpath. We have our points that we selected. And we're going to go into the parameter. And now we're going to select tool library. It's a 210 countersink. And we're going to go back to the normal mill inch tool library. We're going to go to filter, turn them none. And we're going to use the, geez, I swear these icons are different in every version. Spot drill. Let's do a 1/4 inch spot drill, and it should call it tool 3. There we go. Okay, I'm not going to mess with this too much. We're just going to come in here. Let's do 7,500 RPMs, 10 inches a minute. And then we're going to go ahead and turn the coolant on. Oops. I've been staring at computers too much. So I'm going to say spot 1032s. Okay. And I reinitialize speeds and feeds. We're just doing a spot drill. I don't care much for these. I turn these off. They just drive me nuts. We're going to recheck. Here's how we're going to do this. And I haven't set any of these. Clearance is going to be 0.5. Retract is going to be where you're going to start drilling from. Top stock is 0. Oh gosh, everything's incremental. We're just going to switch to absolute. You can get absolute and incremental to spit out the exact same toolpath. But yeah, so since it's a 90-degree spot drill, we're going to take 210 divided by 2. Oops, an extra plus in there. We're going to take negative 210 divided by 2. That's how deep you take a 90-degree spot drill. Spot 1032s, drill. There we go. Coolant should be on. Plane should say up 1. Okay, we're going to save that to our defaults. And green check mark. Save it. Oh. Why is this? Oh, whoa, what's going on? Weird. Whoa, that was weird. I swear I had that op selected. Let's see, let's turn on the vise. Turn on the solid. Not that, this solid. Man, my brain is fried. So you can see the tool is going to the exact diameter of the drawn countersink. And you can see we're at C.1, and then we're going to feed down to negative 210. All right, I'm going to give that tool a tool holder. We're just going to use the same tool holder as the other. Oh gosh, we're going to go edit the tool a little bit. It won't let you stick a tool out further than where the shoulder length is. And then we're going to say this tool, we'll leave it at 3 inches. We'll just say there's like a flute ground in about 1 inch long. So we'll just call that the cutting length. Cutting length is actually down here, but whatever. So now it'll let me stick the tool out as short as 1 inch. Here, we'll just do this. We'll call it 1/4 inch spot, 90 degrees. There we go. And we're going to stick it out 1.5 inches. 1.25. Whatever, doesn't matter. Generate toolpath, save it, take a peek at it. Now we got a spot drill. And as we're doing this, we're going to be adding our tools to our other tool library. Okay. All right, so now we got a spot drill. We're just going to copy that. Drop this down. And let's go ahead and get a drill. And we want, what is it? Number 21 drill, I think. There we go. Go ahead and edit the tool. Usually these are 135 machine screw drill. Let's just say it's, let's say it's 2-inch long drill. And the flutes are 1.25 long. It's like a machine screw size drill. Okay, so we got our number 21 drill. We're going to give it a surface footage of 200. Let's say it's a carbide drill, actually. Number 21 carbide drill. And we're going to set the default to drill. Yeah, sure. And then we're going to set the feed rate to 2.5 thou. And we'll just round that up to 25. And actually, we're going to give it through tool. Okay. Oh, let's give it a holder too. Let's just say we have a lot of those holders. These guys here. And I said, how long was the tool? How long did I say? Excuse me. We're going to say it's 2.5. We're going to say this is 1.5. Sure, sounds about right. Doesn't have to be perfect. Okay, so we're going to stick this out 1.75. Perfect. It's going to automatically import that tool's preferred drill method. And I'm going to right click on here, turn on the stock geo, click there, and then we're going to take a peek at this drill tip calculator. So it's going to import the tool angle, which is why I always set it for drills. I don't like using, what is it? Is it tip? Oh yeah, they've changed this. I don't like using that because if you accidentally leave it on, then your spot drills go way too deep. So I'll toggle this to make sure the values are fresh, and we know we need to go 33 lower than that to break through, so we'll just go down to 50. Okay, so our tool is going to break through. Go back to the toolpath manager. Oh shoot, I'm an idiot. We're not drilling through. Oh gosh, we're drilling to that depth. That's why we extruded it to that depth. There we go. And I guess, you know, be pedantic, we're actually not drilling to that. We're drilling minus 33 is our full diameter. But this should be enough for a thread mill. So there we go. We got our spot and our drill. And what I'm going to do is I'm going to, let's do this. You know what? We can just use these guys. I think we already have them selected. So I believe, I don't normally do this, but I think you can take the drill toolpath and change it, yeah, to a thread mill. So we already have the points selected and it knows it's associated with those minor diameter arcs. So we'll have to change a couple things. In this instance, I think we're actually going to create a tool. We're going to create a thread mill and we're going to tell it 32 is the pitch. I like to do this. I just take 1 divided by pitch cutting length. So we only have, this is a single pitch thread mill. And let's see if this is at 1032. So for our miners 150, I want to say there's some thread mills by SET that are, I guess I could look up their tools real quick. Let's do that. SET thread mill. And then I'm going to go to SET tools, go to their products, look at their thread mills. Here, I'll show you guys. And these are going to be UN threads, UN single profile. And we want, oh, that's funny, they have them by 138. Yeah, that makes sense. And it looks like, let's see what we got here. Length of cut. We want B to be a minimum of 380, which is this guy here. So we're going to pick this guy here. This is what we're going to draw. I'll just leave that over here on this side. Man, everything is white. This is too bright. Okay, so we're going to create this thread mill, and the cutting diameter is going to be 0.138. Overall, let's see if it says what the overall, I think it's 2 inches. Yeah, so the overall length is 2 inches. Okay. This is how I like to draw them. This isn't perfect, but I do it for a reason, so that when I'm running backflot, I just make the shank. Oh yeah, what is the shank? I don't have it to measure. 20,000 is Q. 75. Yeah, okay. 75 is the neck diameter. And I just tell it that the shank is the same as the neck. And the reason why I do that is it's so much easier to visualize this way. And the shoulder length is going to be 0.5, right? So we have our 2-inch long tool. This is the section we're only concerned about. I just like to draw them this way because then when you're looking from the top, I can turn off the holder and make sure it's cutting to the right diameter. If you draw all the other stuff, it just kind of gets in the way. It's very, very me specific. You decide what you like for thread mills. Okay, 2 inches cutting length. It's 1 pitch. 32 threads per inch, ½ inch. Okay, looks good. We're gonna run this bad boy at 12,000 RPMs. It's a 3 flute, I think. Yes, it's 3 flute. Yep. Okay. So if it's 3 flute, I'm probably gonna feed it about 10 inches a minute, maybe even 15. Whatever, we'll do 10. We'll keep the plunge rate not too crazy, and we'll just use normal flood. Okay, so now we have a thread mill, and we'll use the exact same holder. We have a lot of these. What did I say? Sure, we'll just do that. Okay, so it knows, and we're going to turn this to where is how I would do this in the machine. So we're doing an ID thread, and since the arc that we selected was 159, we're going to override this. So 190 is the diameter of a 1032. I'll show you a cool formula here. So this is the number thread major diameter calculator, and it's going to be 0.060 plus n times 0.013. How does this work? So we're going to take 60 thou plus, in this case, an n times 0.013, and you're going to end up with 60 plus 0.130 equals 0.190. This numbered thread calculator works forward and reverse, and what I mean by that is if the n is double aught or triple aught, this becomes -1 or -2, and then you would subtract. So like a 256 is 0.060 plus 2 times 0.013, which is 26. You end up with 86 as the major. Yeah, it's a cool formula. Anyway, the major of a 1032 is 190. So this is how I've been doing my thread mills for quite a few years now. I don't remember when I started this. It's been a while back. I will go in and tell it a little bit smaller And the reason why I did this is there's a machine I ran where if I was giving it positive wear comp, it would go really, really slow. So I just start small. I used to do test holes on other pieces of material. I don't even do test holes anymore. I just do it on my part. Make sure I clean my collets and make sure I know the exact diameter of the thread mill. And yeah, haven't had any major issues this way. So we know we have one tooth, and you can lock these things so that this doesn't accidentally change. And this is the pitch. This is what's going to determine the helix angle, I guess, or the helix, depth between passes. Oops, sorry. We're just going to leave all this stuff the same. We're cutting to 0.188. We would dial this in at the machine, right hand thread, bottom to top. It already knows we're trying to climb mill. And here's what I like. I like perpendicular. Let me do this. Turn this off, turn that off. End at center, start at center. I think this is how I do it. And I just keep this 0. And it will, the lowest number it'll let you get here is 1 degree. So I hate this because this limits the amount of thread that you have on the bottom, and I just turn it off on the top. I just do a perpendicular entry in most materials. And in aluminum, which we're going to call this part, I just shoot straight for the diameter. Because, I'll show you. I can't do it in that field, but I'll do it in this field. 0.190 minus 0.159 divided by 2. That's the amount of radial thread thickness from crest to trough, I guess. We're really not cutting that much, and it's like a small tool. So what I typically do in aluminum is I just do multi-passes at 0. Just let it get rid of the deflection, and yeah, dial it in that way. That's how I cut my threads in aluminum. It's pretty quick, no big deal. Yeah, so at the machine you'd probably have a -1-ish comp radially. So it's just going to take 1032s. Wear comp, override geometry. I'm going to take a peek at my phone here real quick. See, you texted me. Oh, my phone's dying. I'm just going to put it on airplane mode. All right. Okay, so we got our, actually, did I ever set that? Yeah. So we got our speeds and feeds set. We got a comment for the operation you'll see on the controller. We know we have one tooth. We know the pitch. We know the diameter we're cutting to. We have a nice square lead in. I'll show you in a sec. 3 multi-passes. We would dial this in at the machine. Next, we're going to do our depth. Oh gosh, go away. So our retract, we're just going to leave that. Feed plane, sure, why not? 0. So if we need a minimum of 380 of thread depth, we know we need to go at least 1 pitch past that, or at least half a pitch, rather. So 15 past 380 is 400. So we'll just go 420. I'm just going to do absolute minus 0.420. Okay, that's it. I'm going to go ahead and save this to my defaults too. Just so I have my lead in and lead out. Just double check real quick. Alrighty, I believe we're all good. So now what I'll do is I'll save it real quick. And I'm going to go ahead and do this. We're going to go to the Geo, turn everything else off. Why do I have... Let's hold on a second. Let's get rid of this guy. There we go. Okay, so we know these are drawn at the minor. I'm actually going to change these to green. This is how I color code my thread milling. I change these to green. And then what I do is I draw the major at red. Yeah, we're in red. just so I have a visual representation when I'm backplotting the toolpath. You'll see what I'm talking about here in a second. All right, so now we have our solid. Oops. We have our solid. Wait, did I do 210? Oh gosh. Okay. I must be tired. It's Friday. My software has been messing up all week. Okay, so what we can do is one quick way to edit a bunch of entities, specifically arcs, is you can just go to Analyze Entity, which is going to be, I think it is going to be, I don't normally use, yeah, here. So we'll go to Analyze Entity, and this is supposed to be 0.190. And whenever I'm mass editing stuff like this, you can just click on that, paste, that, paste, that, paste, that, paste, that, paste, that, paste. 90 even, 90 even, 90 even, 90 even. Okay. As I was saying, before I messed that up, so now that we have the minor and the major of the thread drawn, so now when we go to backplot this toolpath, I can turn the holder off, and this is why I like drawing the shank as just the shank diameter without, you know, any extra larger section here. Because now it's like really easy to look at, right? So I can see we're cutting. If I go to measure this, it's going to be 1 thou, I think. Yeah, see? So that would be the amount that I would comp in the machine, and you can do a little bit more. So then we would helix 1, 2, 3, next hole 1, 2, 3, and I want to show you the lead in and lead outs. So it's a nice straight entry, and at the bottom, you don't lose any thread here. If you have that helical entry, this will be a helical move, and you'll lose like half a pitch of thread. It really matters in narrow space parts where you need to get close to the bottom of the hole. This one we didn't get that close. And just to show you that we have clearance. Oops, I forgot to call this drill. Getting sloppy here. So if we look at the depth that we come down to, you can see we're way down here, and then our thread mill, this is about where we were. Our thread mill comes to there. So we have quite a bit of clearance, 50 thou clearance or so from the bottom of where we drilled. Perfect. 3 passes, boom, 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 boom. What I'd probably do in the machine the first time I ran this is I would run the first one, stop it, or like I would stop it here when it's coming out. I would drop the rapids. 1, 2, 3. I'd drop the rapids really low, and then I turn on single block, and I'd go to that move, and that's where I would stop it. And I'd check it with the thread gauge. And if I had it dialed in, I'd just let it run. If not, I would reset, move the tool out of the way, make an adjustment, rerun the first hole, get it dialed in, and then let it run through, and then stop it after the second one, check it, and if it's good, I'd let it run through the rest of them. Because it's aluminum, it's probably going to cut the same. All right, so there we go. So now we have our entire next part, the Titan-1-2M. Let's go ahead and see how Verify looks. It's pulling up on the other screen. Pull it over here. And we selected the fixtures, so I can just turn that on and off, just like I did on the 1M. Stock looks good. It's placed as it should be. We'll turn the simulator on. Let's get fancy today. Let's do this. I'll measure it now. Actually, we're just gonna exit. So this happens a lot, and it's okay. If you ever want to get the sim set up properly, we have it set to auto right now. Yeah, so we can go to manual. I'll just leave it at 0 for now. But the distance I'm going to measure is how far is it from my offset to the bottom of the vise. I'm going to take that number. This is usually the right number, not always. It depends on how your planes are set up and how the machine's defined, blah, 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 blah. We'll go into the sim, and we're going to add that value in our Z, we're basically saying like, hey, our whole setup is this far away from that number. Okay, I'll save it. And we're going to rerun verify. Oops, I have my vice on. That's going to bug me. Let's turn that off. Go back to verify. Oh, I don't even, there was an error. I don't know what it was, but it was only up for a second. Okay, I'm going to turn on the simulator. Ah, shoot, we're exactly where we were. That's not annoying. I think that error had something to do with the sim setup. Let's get that. Let's try to get that right. Let's go back to auto, see what it does. Sometimes the sim misbehaves very badly. Okay, yeah, it looks like the same number. So we'll just come in here, click on axis align, make sure that's on. We're going to pick a point on the table, and then we're going to pick a point on the vice. 2.95. I'm going to subtract that number from my Z value in the sim setup. Let's go. This is just a quick way to get straight to there. 2.95, I believe is what I said. Minus 2.95. I think that's going to be, let's look, see if we can figure out what that number is. 2.95. I don't know what that number is. It depends on how the machine's defined. It has something to do with that. Half the time it doesn't make sense. Just gotta play with it for a sec. Okay, so we got our Z value. I bet the Y is off. Sure, let's do that too. Let's do that. Let's pick, try to get like the very, very center of this arc. It's sad that it doesn't pick up center points or anything in this menu. So we're guessing, but it'll be close enough. 1.77. I think you can change the, whatever, we're just going to call it 1.76. So that would be plus. Go straight to the simulator, 1.76. And you can kind of see it's off. Am I seeing things? I bet I went the wrong way. Oh, yeah, it's definitely showing an error. I'll look at that in the video editing. Maybe I can pause it on that frame. Okay, no, we got it. Sometimes you just have to play with it, and that wouldn't be exact. Yeah, you can tell it's off. We're just going to leave it at that, though. That's no big deal. So we'll leave stop at ops. We're going to leave the stock on. There we go. We're going to ramp down. We're going to finish face. You can tell right here we're at. Let's see if it shows. Yeah, these are all machine coordinates. I swear there used to be a view where it showed you your actual whatever. So we're going to deburr. We're going to spot. Here, I'll turn it down and I'll let it play. We're going to spot. Then we're going to switch to our drill. We're just going to through spindle coolant, drill to depth, drill to depth. Boom. Now we're going to thread mill. So we'll watch this guy a little bit slower. So we're going to come to the center of the hole, and these numbers, if you're in backplot, they're right. I don't remember why this. I swear at one point in time it showed the numbers, but anyway. So we'll come in, we'll plunge down. You see how we have that clearance there. These colors are dictated by the proximity numbers you set up in the sim. I believe you can change them. It's a little bit of a pain in the butt, but you can change them. And notice how we lead straight back to the middle. Not sure why that's showing it going all the way to 1/2 inch in between every. I'm trying to think if it would do that or not. Let's look at the settings here. Multi-passes. Let's look at linking, feed plane 0.1. I guess, yeah, I guess it would do that. Whatever, let's open it back up. So then we would get our threads in there. Boom, that's op1 done of the Titan-1-2M. And we're just going to basically copy what we did on the other part. And you can leave the sim open in the other page. A lot of time, or other screen. A lot of times I'll do that. I'll just leave the sim open on the other side if I'm working on a crazy part. Okay, so that was our op1 setup. So we're just going to go 101. It's going to be Kurt DX6. We're going to call it op2. Boom. We're going to copy our op1 vice. We're going to select all entities. We can click on this, copy it to op2 vice. There we go. Save it. And we're going to leave the solid on, and that's it. And we're going to come to, I believe the front should work this time. Yeah. And then we're going to change colors, just so we know it's the op2 vice. Select all entities, and we're going to rotate about that center point, 180. We're going to move it. Let's reselect. Let's pick that. Perfect. That's good enough for now. Okay, we're going to go to the op2 plane. And the reason why it's a different offset is a lot of times I do this with different fixtures because then I can leave offsets in the machine. And if you're running multiple parts, you got to run into quality. It's really handy because then you know your numbers are in the ballpark. Or if you have offsets that just stay where they are, you don't have to mess with anything. So, same thing. Let's figure out how to get this number. That's 1.65. Notice how that's the same number as last time. Select all entities, transform, translate. 950. We got to move the jaws, move the vice. That's going to be, how far does this need to come back? 125. Makes sense. That's exactly how much stock we had. So, copy this. And you can be lazy. You don't have to do all this stuff. You don't even have to model the fixturing and stuff. I just like having things where they should be. Like if you ever wanted to make a setup sheet for an operator and you're in like 1,000,000 of these. So this is where booleaning those all together comes in handy. I don't have to select them individually. There we go. op2 setup. And if I was running this part and I had a flatness call out or whatever, you could clamp it down, run the rough face, unclamp it, clamp it, finish it. But we're not going to do that. We're going to be lazy. So looks like we have that dynamic. So we're going to get the stock geo and the profile. And we're going to do the same thing. We're going to transform, project this guy while copying it. Got to be careful to copy when you're moving geometry you used on another toolpath. It'll make the toolpath dirty. So you always got to be aware when you're moving geometry that's been used before. Okay, So you notice we're in our op2 plane. We'll just take a peek here. Make sure these numbers make sense. Yep. Okay. So if you recall from last time, I think it's 200 stock. Yes. So we're going to go ahead and from the outside, we're telling it where we're starting to cut, telling it to avoid this. And I think the depth was 10,000. Yeah. So we'll just let her rip. Stays away from the part. And if you have a big hat, you can do this and get it close enough, and then you can probe the real part. A lot of times I'll write a probe cycle in here to do that. I guess, yeah, like a manual entry. If you know the codes, you can just put like a M00, probe X and Y, something like that. And then you could add probe cycle here. Anyway, no. Okay, so we're gonna rough the face of the real part. Oops. Add this guy. Green check mark. Looks like we're stepping down 50. Add this guy. Finish that guy, and then here we go. All right, we're gonna do something cool on this one. Let's regen that guy. All right, let's do something. I should be teaching things in every video, so let's do something like this. Let's make a level, and we're gonna call it level 8. And it's gonna be 1, let's see, Titan-1-2M engraving. Let's go ahead and engrave the part number on here, because we might as well build a tool library. So let's do this. We're going to create letter. Oh, this is going to be, it's always a pain in the butt when you first draft something. So we're going to do that. Let's do 1/8 of an inch. It's nice when this is working properly. It'll give you a decent spacing. I always add like 10 just to give it more room. And then you can manually place it. That looks pretty centered. Sure, why not? Titan-1-2M. It's at 0. So what you can do is you can just do a contour, and you can click Window, come to this view, select all of those, and then click a start point. And let's do this. We're gonna, I doubt we'll have one, so we'll just take a, let's do this. Let's get a ball and mill. This is how I do my engravings. I've been doing it for years like this. Let's pick, the closest size is gonna be 1/16. And it's actually going to be a 3/64. So 3 divided by 64, it's like 47. Let's just say this is 1.5 inches. This is just going to be like 0.1 or something tiny. Shoulder length, 0.1. 3 divided by 64. 3 divided by 64. It's not exactly how it would be, but whatever. We're just going to call this 3/64 ball. Run this bad boy. Crank it up. I usually engrave at like 30, 50. Doesn't matter. Sure, it's a 4-flute ball and mill. Okay, give it another holder. Like I said, we got 1 million of these holders in this shop. Cool. So here's how I engrave. We're going to go to 2D. We're going to turn off cutter comp. We're going to turn off lead in and lead out. We don't want it to, we want it to drive exactly on the letters. So the way I like doing this is I use clearance only at the start and end. And this is where I put the value I normally have for my retract. My retract is only going to be like 25. Feed plane is also going to be 25. Top of stock is going to be 0. Depth is about 1.5. So what we're telling the machine to do is, hey, let's go to rapid 1/2 inch, then rapid down to 25 thou, feed from 25 to -0.15. So it's only going to do that little tiny feed move exactly on the letters. And I've never had any issues engraving like this. If it's a rougher, tougher material, I slow down the plunge and whatnot. So yeah, we're going to drive. See, we got these nice little tiny moves. Boom. It's like a 10-second engraving. 6 seconds. So now, when we go to verify everything, oh, forgot to change it to the op2 vice. Let's do actually fixtures. We'll add from level op2. Why is it? There should be an option that says make active. I don't know why it's not doing that. I swear the learning edition acts so weird. Whatever. We'll just remove this one. Whatever. I swear that at work there's an option to make one the active one and one not the active. So you can leave them in there and toggle between the two. Okay. So we got our, we got our verify all set up. We'll get fancy, we'll use the sim. And, oh gosh. I don't know how to look for the second op. This isn't, whatever, we're just gonna skip through this. Okay, so we'd get through our op1, right? We already know that each individual setup looked good. Okay. And then we get to our op2, get rid of the hat, rough face it off, finish face it, deburr. Oh, did I? Oh yeah, that's all we're doing. I don't know why. Boom. Then we got a nice little engraving. Ta-da! Anyway, that is the Titan-1-2M banged out in hopefully half an hour or so. I don't even know how long I've been recording. So yeah, like, comment, subscribe. I'm gonna try to just bang out as many of these as I can. That makes sense. Maybe in some of these in the future I'll draft them outside of the video. But yeah, hopefully you enjoyed that. Subscribe for more, and I'll try to teach you as much as I can about Mastercam. Peace.